Hi everyone and welcome to the Allplane Podcast, where we talk with the movers and shakers that are redefining the future of commercial aviation. As usual, before we start, I would like to remind you that all previous episodes of this podcast, as well as many other aviation stories, are available on the Allplane website. That's Allplane.tv. Allplane.tv. Our guest today is Aleksey Matyushev, founder and CEO of Natilus, a Californian startup that is developing a truly disruptive air freighter concept. Aleksey, who has an engineering degree from Embry-Riddle Aeronautical University, has been working at the technological frontier of aerospace science, both in civilian and military aircraft programs. His current project, Natilus, is named, minus the letter U, after the fictional craft devised by Jules Verne in his novel 20,000 Leagues Under the Seas. But rather than a submarine, what Natilus is developing is an entire family of blended wing body aircraft designed to carry primarily air cargo. A blended wing body is a type of aircraft where there is no clear distinction between the fuselage and the wings. This gives the Natilus family of aircraft an obviously futuristic look. But this is far from being the only truly revolutionary aspect of what Aleksey and his team are trying to achieve. The Natilus family of aircraft are also designed to have a very large degree of autonomy, so if regulators approve, they will be able to operate without any human on board. Natilus is also working with partners to incorporate hydrogen propulsion as soon as this technology becomes commercially available. So quite a lot going on, but despite its moonshot nature, or perhaps more accurately, because of it, the Natilus project has caught the attention of quite a few leading technology investors, and it has also racked up orders north of $8 billion in pre-orders from several air cargo industry operators. But I think it is best if we hear it all directly from Aleksey. So, without further ado, let me welcome him to the podcast. Hello, Aleksey. How are you?
Hey, doing well, Mikhail. Thank you.
Well, thank you so much for making time to be here on the podcast today. This has been, I guess, a good week for you guys at Natilus because you just announced a new order for your very innovative cargo aircraft. But let me just make a short introduction. You are basically the founder and the CEO of Natilus, which is a startup based in the San Diego area in California, developing a new family, a new generation, a family of autonomous aircraft. There are quite a few aspects here that are very innovative. Autonomy, sustainability, and also the concept of developing a whole new family of aircraft that are designed specifically for the cargo market. So the company is called Natilus, and well, like every other guest, I would like you just start by explaining us a little bit about yourself, your background, and how you ended up starting this company, and then maybe we can move on to the story of the company and where are you now in terms of development and the next milestones.
Yeah, absolutely. So thank you so much for having me here. A little bit about my background. So I graduated from Embry-Riddle University here in the United States with a degree in aerospace engineering, specialization in aerodynamics. And that's actually where I met my co-founder, Anatoly. So I've known him for quite a long time. And then this was kind of like in the early 2000s, well, actually late 2000s, early 2010s. And the very light jet wars were starting to come alive. So a lot of the Cessna companies, Cirrus, Diamond, and Piper were building a family of these very light jets, kind of almost indicative of what we see today with the eVTOLs, trying to darken the skies and create a day taxi type of operation. So got brought on board the program relatively quickly. And my first couple of months, I kind of got kicked into doing a wind tunnel test, which was very exciting. So learned quite a bit at Piper, became head of aerodynamics there relatively early. Got to see a lot of really cool concepts go from clean sheet all the way through certification. Helped have a really large role in a lot of those. Learned quite a bit through just not only the wind tunnel testing, but also the aerodynamics of flight testing, seeing how everything kind of jives together. And then it was kind of time to find something new. And so I got recruited to go work on the West Coast, specifically military projects, doing cutting edge unmanned technology, and specifically working with the likes of Skunk Works to help develop some very innovative concepts for the Department of Defense. And so I did that for quite a while. Some of the programs have now been declassified, but kind of represent some of the more cutting edge, I would say, novel technologies, both for unmanned as well as rapid prototyping, specifically in carbon fiber in the industry here in the United States. And then got kind of tired sleeping under my desk, designing these multi-million-dollar airplanes, and I never get to really fly on them. So have an entrepreneurial spirit. I started an industrial design firm. And at that point, Kickstarter was really on the up and up here in the United States. They were one of the first kind of platforms to allow for hardware projects to be let on. And so kind of teamed up with another individual to work on iPad amplifiers. And so we did that successfully and grew that into a very successful product platform. Went into charging cables, also just wall chargers as well for e-commerce and whatnot. And so grew that into a successful business, but we kind of stumbled upon this really fundamental challenge of how to move goods over from Asia to United States. And being an e-commerce platform, we kind of had two facets of it, of course, doing the engineering work in the United States, but manufacturing over in Asia. And then we would ship internationally a lot of our products, but 30% of our business was international. And so kind of trying to bring goods from Asia over, a lot of the retail partners that we were dealing with wanted product next week. And so as the factory was producing those pieces, we had to get them over really quickly, but the only way to do it was via air freight. And so we would lose all our money on moving the goods by air freight. And of
Yeah.
course, we would be splitting some of the loads by ocean. And so that's kind of how the genesis of the idea of the company came about. And then the last piece of the puzzle too was, of course, shipping to international customers. A product might be, 15 US dollars, but the shipping would be $35 to go into Europe or, to India or, Israel and whatnot. And so nobody really wanted to purchase a $15 product and pay double almost of that as far as shipping goes. And so we saw the problem kind of in the logistical space on both sides of the puzzle. And so that really was kind of got us thinking is how maybe you could change the unit economics, essentially trying to capture the timeliness of air freight, but more at a cost point closer to ocean freight. And so essentially that was the really big idea behind Nautilus when we started it.
And I think still a very current issue because we are seeing right now lots of disruption the supply chains because of geopolitics and wars, piracy, all sort of different things that can happen to ships when they are moving around the world and sometimes in troubled areas. So you started with this idea of basically simplifying the logistics between the US and Asia, because I think your very first concept, at least from what I read, was to do some sort of seaplane taking off from the open seas, I think, and then just to make it more agile, I guess, not using airports, but just going from port to port. But then I think that has changed since that very initial idea. Is that right?
Yeah, it was. So we thought we were really clever when we started the company. There's actually a loophole in the FAA regulations. It's not, a loophole, but it's just kind of a different way of thinking about it. Whereas a wing and ground effect vehicle, which is an airplane that flies, within one wingspan of the water or the ground, is actually certified by the Coast Guard. And so you don't have to deal with the FAA. You don't have to deal with a lot of the heavy regulatory basis that they can kind of impose on you. And so it felt like the path to market was a lot cheaper and faster. And so especially raising money from Silicon Valley, it's always a question of how quickly you can get to market. And so the idea was, look, we're interfacing with cargo containers at port anyway. Why don't we interface with, air freight shipping at port as well? And so we ended up building a prototype, a seaplane prototype. But as we were building the prototype, we started talking with our future customers, such as integrators like the UPSs and the FedExes of the world, as well as major airlines. And it kind of became really clear that a lot of these airlines, they built up infrastructure in landlocked areas, and so they don't really interface with port. And so for them, it would be a fundamental shift in their business to send cargo towards the port, and it would kind of it was just a non-starter for them. It felt like a separate new product. Nobody knew what exactly it could be. And then as well as there are some challenges, especially with loading up airplanes at ports. What if, there's a wave and the airplane, breaks a wing or something like that, it could sink. So there's a lot of things that we thought that we could, from an engineering mindset could essentially handle. But at the same time, we had just this huge pushback from customers that this is not the right interface point for us for air freight. And so we kind of shifted the product. We gained one more insight as far as that goes. And then essentially brought into a family of blended wing bodies, addressing kind of all those key concerns that they really had. I guess following the Silicon Valley mantra of, really listen to your customers and shaping the product. And so that's kind of where the direction ended up today.
Mm-hmm. Yeah, indeed. Actually, we must point out that there's a couple of startups in the US that are currently pursuing this ground effect vehicle concept. One of them, Region, actually, it's doing quite a lot of progress lately. But they don't plan to carry goods across the Pacific Ocean, at least not yet. I think they have a different concept of moving people on along coastal communities and all that. But yeah, that's another interesting technology that is currently being developed as well. But then let's move back to your project, how it evolved, because you mentioned the blended wing body concept. One of the things that basically stand out when you look at what you guys are designing is precisely this. Well, there are a few things. One is the blended wing body concept. It looks a bit like the B-2 bomber, or this kind of plane that is just like a wing. I think that's a concept that has been studied by Boeing and some of the major aircraft makers, with the idea of developing an airliner. I think at some point in the late 90s, there was even a pretty advanced proposal to make it a reality that didn't fructify. Why did you opt for this concept? Because it looks like it adds a level of complexity here.
Right. So you kind of hit the nail on the head. So the blended wing body has been studied for quite a long time for a variety of reasons. It makes for kind of a bad passenger airplane. So just for your audience, the genesis of the blended wing bodies was started in McDonnell Douglas out of the Long Beach office here in California. And they got a pretty advanced studies done on it. So they identified a couple of key problems surrounding it. The first one was the pressurization aspect of it. The second one was the stability. So both longitudinal and directional stability challenges. And then the third problem was kind of operationally. It had larger wingspans. And then also the most important thing was when the airplane banks, the passengers that sit on the outboard side are closer to the windows. They experience more than normal or higher G forces. And so that's really kind of, along with the last problem, I guess, is being ingress, because it was hard to get all the passengers out in 90 seconds or less out of the airplane as well. Kind of really put a lot of hurdles on the concept in general. And so what happened was then Boeing purchased McDonnell Douglas, and of course, two different engineering teams with two different, I guess, mental approaches to it. The Seattle office absolutely hated the idea, as the McDonnell engineers kind of came into Boeing. And so it was really quickly squashed, but not before NASA teamed up with what the engineering team was at that point to build a scale prototype of it, right? And so that flew in the late 1990s, early 2000s. And so a lot of data was available, but a lot of that data is proprietary. So they would show you trends in the technical papers, but never the numbers. So nobody really knew how good it was, except the Boeing and NASA, where the papers and the data actually was held.
Aren't there already lots of data points based on some planes with this structure that have flown, like the B-2 bomber, for example, the new bomber, I don't remember the name, B-21, I think it's follows kind of the same concept. I think even the Germans had one blended wing body concept during the Second World War that I don't know if it managed to fly at the end or not, just towards the end of the war. And then scale models, like I think Delft University in the Netherlands, they tested as well a really small scale model not long ago. So is this something that, from a structural aerodynamic point of view, are there many unknowns there?
Well, I guess taking a step back, maybe a better question to start out with is what is a blended wing body? Like, what do we actually classify as a blended wing body? And unfortunately, not like the aerodynamicists got together and created a definition just yet. So it's kind of been really loose. But from my perspective, a flying wing is something like the B-2 bomber, like the B-21 Raider recently, and a lot of the German prototypes, as well as what Jack Northrop did, is where the lift of the airplane is actually coming 100% from the fuselage wing combination, right? And so it's almost ubiquitously a flying wing. Whereas a blended wing body, the idea is you take a flying wing platform, but you inject a fuselage section inside of it. And so the fuselage section and the wing behave similarly, but not exactly the same, both from an aerodynamic perspective. So to kind of give you a perspective in a more, I guess, numbers context. So like a tube and wing airplane, the wing produces 90% of the lift, the fuselage produces 10. On a blended wing body, you have a 50-50 split typically, where the wing is producing 50, the fuselage is producing 50, and there's a distinctive fuselage. And then you have like the flying wing concept, whereas the entire fuselage wing combo, there's really not a good separation there. And so it's a wing that's producing 100% of the lift.
Hmm.
And so there's the kind of like in the spectrum of the blended wing body concepts, there really hasn't been a full scale prototype ever flown. We kind of briefly mentioned the NASA and the Boeing lookalike. I think that was the closest representation of a blended wing body.
How big was that scale model? How
Yeah,
big?
that's the model. But like if you think about the University of Delft concept, that was a flying V wing. And so I
Okay.
would classify it as a wing, not particularly as a blended wing body concept. And
But
so
that
go ahead.
NASA one, how big was it? It was like a scale, like a really like a toy plane, or was like a something of certain entity?
Yeah, they really pushed it. I think, don't quote me on this, but I think it was closer to 20, maybe 25 foot in wingspan. So
Okay.
although it had, pieces of RC inside of it, it started to look like very representative and very large, I would
Hmm.
say. They really tried to push it with as much funding as they could to get the data that they needed.
Okay.
But that concept, just to kind of close that out, is ended up kind of solidifying a lot of the big unknowns that they had with stability, spin characteristics, and then like the flight control laws slash stalls. And so all those kind of pieces that were, I guess, identified as risks in early studies from McDonnell Douglas have kind of proven themselves out to be exactly what people thought. And so over the next 20 years, folks and companies have been looking for solutions to those challenges and essentially enabling to bring the blended wing body to market.
Hmm. And why did you think it's a particularly suitable concept for what you're trying to do?
Yeah, so two things happened. Well, it's really one thing that kind of led to this whole shift in for us as a company into the blended wing body design. So, with the kind of emergence of e-commerce, specifically with the rise of the Amazons here in the United States and the Rakutens, JDs on a global level, the densities of cargo started to get really low. And so, traditional tube and wing airplanes are cubing out on volume before they top out on weight. And so what the industry has been really looking for over the last 20 to 30 years is a more volume-centric design. And so when you actually study a lot of these new generational concepts, you have to move away from a tube and wing to get to some kind of meaningful impact on that. And the blended wing body naturally makes sense. And so essentially taking the blended wing body idea, but then specifically focusing it on the freight sector where you don't have as much issues on pressurization or egress or the G loading, as we talked about with the passenger sitting on the outboard side, it kind of solves a lot of those problems naturally. And so I think where the blended wing body was firstly purposed for the passenger markets is really why it didn't really move forward. But when you purpose it for the passenger market, I'm sorry, the freight market right now with the kind of the new trend with e-commerce, I think it starts to make a lot of sense as a product.
But if you're looking for a concept to carry more, let's say, volume-centric cargoes, why not just make a conventional airplane more kind of bubbly, a bit like the Beluga, what Airbus is doing now with the Beluga? They are repurposing some of the old Belugas to do precisely this sort of large volume, but not necessarily very heavy weight cargo transport. Isn't it easier to just take a conventional aircraft and make it wider, but traditional
Yeah.
in the concept?
Oh, you totally could. So, I mean, you could buy an existing 737, stack a huge fuselage section on top of it, somehow prove out the aerodynamics, and off you go. The problem is that the other two pieces of the puzzle, specifically sustainability and efficiency. So the belugas are, there's a lot of drag. It's a lot of frontal area aerodynamically. And so what you gain in volume, you lose in efficiency. And so the unit economics don't work out quite as well, where they actually break the business if you start thinking about a beluga. The belugas are really great in transporting high value cargo and very specialized cargo. So things like, for manufacturing of wings or fuselage sections for Boeing and Airbus. That's really where they found their niche. But operationally wise, when you scale it up, the fuel burn based on the drag alone is kind of destroys those types of, I guess, aerodynamic concepts.
If you make the fuselage, you expand it, or you flatten it a bit, it's actually you end up with a blended wing. Sort of,
Body,
yeah.
yeah.
So
The
sort
question
of.
is, how do you take a beluga and make it more aerodynamic? And the
Yeah,
answer
yeah.
is you end up with a blended wing body.
Yeah, well, but that's only one of the innovative elements of what you're developing, because there's another one, and it's on the sustainability side. You are working on a hydrogen-powered aircraft, and I think you are collaborating with Zero Avia for the powertrain. Well, actually, Zero Avia has been on this podcast twice. Katia Kulinicheva, one of the first guests here on the podcast quite a few years ago, and then Val, the founder, was also one of the guests last year. So I'm quite familiar with the Zero Avia project, and I think you are guys working together to develop also the propulsion for this family of cargo aircraft.
Right. So the answer is we are. And we're excited about what Val and his team and Zero Avi are working on. I think it's incredible. I do feel that they're one of the market leaders in this space. So kind of taking a step back though, so Nautilus airplanes, they're conventionally powered drivetrains right now. So like as an example, our regional uses PT6 engine technology. Some Pratt and Whitney. Our larger products, use comparable GE, Rolls-Royce, or Pratt's turbofans. So that'll be our entry into the market. However, we see that sustainability is a very fundamental requirement for the future, especially when you talk to airlines, like future customers. And so one of the challenges with hydrogen technology in of itself is it's very volume centric. And so when you take an existing a tube and wing airplane and you start injecting hydrogen technology in these fuel cells, you end up removing a lot of the revenue passengers or the revenue cargo out of it to help maintain mission performance. And so naturally, an airplane designed around e-commerce and more volume-centric cargo, we have volume for days. And so the blender wing body is a natural host or a first kind of instance of how you can inject hydrogen technology, specifically these large fuel cell tanks, without losing any mission performance or payload. And so we kind of believe that is, and cargo is actually a very interesting first use case for the technology too. So blender wing body with cargo seems like a huge winner for the first instance of hydrogen propulsion and sustainability.
Mm-hmm. Do you have a time frame for this hydrogen project, or that's something that's kind of vague at this moment?
We're kind of at early phases with Zero Avia. They have their own development timeline that they've published, and so we're kind of waiting for a lot of those technologies to mature. But at the same time, we've started to really look together of how we can marry their propulsion system with our airframe. And so we're leaving room in certain places of the airplane to allow for their technology as soon as it becomes commercially viable and available.
Mm-hmm. Right now, you are working on three sizes of this concept. I don't know if they are all just a scale-up version of each other, or there are some differences. Can you tell us a bit more about all the different types of aircraft that you are working on at this moment?
Absolutely. So Nautilus is a family of airplanes. The first one is a regional freighter meant for Part 23 certification here in the United States, a maximum gross weight about 19,000 pounds, powered by twin turboprops. So it's meant for regional operations. Typical customers would use it for 1 to 2 hour flights, meant to connect regional airports to larger hubs. What's very unique about that initial design is it actually is the only airplane of that payload and size category that can carry standard air freight containers. So that is a huge new first for the industry. The second product is the Elysia. That'll be a 60-ton payload category airplane, more closely comparing to the 767 lookalike performance or an A330. And that'll be North America, transatlantic, inner Europe, and then inner Asia. And then the flagship product, the one that gets our customers most excited, is the Norts. And that'll be your long-haul trans-Pacific freighter, 100-ton plus payload capability, and that's essentially connecting Asia, the global manufacturing hub, and e-commerce to the rest of the world.
So the 100 plus, would that be comparable? I'm just thinking now, what would be the equivalent in conventional aircraft? Something like an Antonov 124, something like that?
Or no, we are closer to 777, 747.
Okay.
Yeah.
And then you have the other one would be comparable, 60 tons payload, that would be comparable to 767 or A330. And what was the payload of the smaller one?
It's about 4 metric tons.
4 metric, and that would be roughly comparable to what? To an ATR freighter or something like that?
Well, yeah, so we very closely comparable to like a Beech 1900 or Cessna Skycourier, but we actually do very well against the ATR as well. So for almost a third of the price, you get exactly the same payload. So it's a pretty good product.
And because what's the total addressable market here? I guess you are targeting companies like you mentioned, UPS, FedEx, these type of companies that are moving cargo relatively fast. Do you have some calculation roughly of what's the size of this market in monetary terms?
Yeah, of course. So the new freighter market development, which is what we're targeting over the next 20, 25 years, I believe, is $270 billion. And so that's currently a duopoly between Boeing and Airbus, and then now Nautilus, which is bringing in a purpose-built product into the market. So I think we're going to do really well as long as we stay on track and are able to make those customer deliveries.
$270 billion, that would be the global market or US?
Global market.
Global market. And what about certification? Because I imagine that's not easy to get certified, particularly because of all the different novelties that you are doing at the same time. So do you have, where are you now with this process? Are you already undergoing some sort of FAA process at the moment? And do you have a time frame for that?
Yeah, so what's really interesting about the product segments that we chose is the Kona, the smaller one, regional, is fits in line with Part 23, which is general aviation rulemaking, both in Europe under EASA and here under the FAA. And so it's actually faster to get the product to market. Typical certification timetables look between 12 to 24 months, with an average being about 18. So where Nautilus is right now, we actually already have FAA approval to go fly optionally piloted as well as manned and unmanned out of San Diego, out of Brown Field where our facilities are, which is very unique to our companies. A lot of drone manufacturers have to go into specific test ranges and things like that. But we've been so careful about how we inject the technology into the aircraft that we got the FAA comfortable enough that we can actually go fly here in San Diego without leaving home. So yeah, the conversations have already been started. We'll file the breadth of paperwork over the next 20 months, so right before first flight. And so right now, so 24 months to first flight, and then about 18 months after that for certification, provided that everything goes well. And so entry into market, I believe, is 2027 right now.
2027. That would be for the smaller one, the Kona. Okay. And what about the money? Because certifying an aircraft is not just difficult technically, but also requires quite a lot of money. My understanding is you are funded by some prominent Silicon Valley investors. What can you tell us about the, let's say, the financial side of the project? And are you currently raising more money, or you're good for now?
So yes, we are backed by some tier one Silicon Valley venture capitalists, which is really exciting for us. I think the conversation or the history and what SpaceX has been able to do to the industry opened up a really interesting door to allow projects like ours to exist and to be funded by those types of revenue, or not revenue streams, but those types of capital insights. But yeah, so a normal business jet program, let's just say in the Part 23 category, most people think it's like $1 billion. It is not. So Part 23, let's say from pencil through certification, depending on the technology, for like a business jet is between 100 and $150 million.
For Silicon Valley standards, it's not that much. Yeah.
Yeah, I mean, it's all relative, right? So we always joke that it takes $10 million to start an airline, $100 million to start an airplane company, and then $5 billion to start a car manufacturing company. So put it all relative, there's a lot of car companies being started right now. There's a lot of money floating around. As long as the market is there, the traction is there, and the team is there to actually go and execute with a solid plan, I think you can go find money to help finance these large projects, as an example. There's been an example, just to give you a little bit of a joke, but Silicon Valley once dumped $100 million into a juicing machine, right? So that we could have built an airplane, but instead we started to build juicing machines. So
yeah, that's what I had in mind. I read some of those crazy stories about Silicon Valley funding some concepts that, well, you read about them and think, well, I don't know.
Yeah, so I mean, I guess those models are more well understood. It's easier to get to markets. So it's easier to prove to investors that when you take that large amounts of capital, that you can get it done. With us, bigger infrastructure projects, you have to wait a little bit further before you show those significant milestones. And so a lot of investors don't have the stomach for that. And so we can talk more about that, but essentially you got to find the right investors who really believe in these big moonshots.
Yeah, and I guess like investors are also looking for the right team to be able to pull off some, like the next SpaceX or the next hardware company as well, like next Apple of aviation, something like that. Well, you have these investors, so you have the idea, you are already working on the concept. What about the industrial plan? Let's say you get certified, you plan to build it yourselves. You have already a factory where you plan to start working on building this aircraft. What's a long-term plan here?
Right. So long-term plan is to be a Boeing or an Airbus lookalike. So design, build, and sell our aircraft. We do have a manufacturing facility here in San Diego already, which is perfect for where we are at this stage of the company. It'll get us through the first prototype as well as through flight test and through certification. But yes, the big idea after that, or the big question is how do you scale up from there to build a manufacturing capacity to be able to deliver airplanes? And so what's really interesting behind airplanes in this company is twofold. The first one is that airplanes in general are pretty low, I guess, a low manufacturing capacity. So we're not going to be producing thousands of these airplanes per year. Right now, initial capacity is scheduled for about 60 airplanes per year. So what a typical factory actually looks like is just a really big hangar with certain stations. And so you bond the wing together, you produce, sheet metal pieces, and you kind of integrate everything together. The company does outsource quite a bit to tier one suppliers that help with I call it the Lego piece manufacturing. And so what the company is left with is just final assembly and integration.
I guess that will still need a lot of money. So we talk about 150 maybe for certification. Are we talking about hundreds of millions of dollars for an industrial facility of this sort?
No, I mean, a hangar space like that probably would cost between $8 to $10 million. And then the tooling alone for production would be probably $20 to $35 million, and just ballpark numbers off the top of my head. So again, we're not talking $400 million. And the key is because this is low rate production. And the way that the FAA thinks about certification still is it's not a lot of automation. And so there's a lot of hand labor, so it really depends on labor rates and just making sure that the key suppliers exist within the ecosystem to help you build it. But yeah, you don't need as much infrastructure as, let's just say, car company, as I mentioned. Car companies, need thousands of units per year, really automated, very different type of manufacturing.
You mentioned automation, and that's actually one point that I wanted to ask you about, because another big, let's say, innovative aspect of your family of aircraft is that they are designed to be remotely operated. I don't know whether we can call them autonomous, because I think they are there's a pilot steering them, but in principle they would be able to fly without a pilot in the cockpit. Is that right?
Yeah, so exactly correct. The long-term vision of Nautilus is to bring remote pilot operation, or depending how what you call autonomy, into the freight sector. And specifically, it's really important for our customers because there's a huge lack of pilots entering the workforce today. And so they actually can't scale their businesses and help, scale with e-commerce demand because there's such a fundamental lack of pilots. And if you talk to pilots, a lot of them say, I want to go fly passengers. It's more capital, it's more prestige. This is what I really wanted to do. So flying freight airplanes is not, I would say, the top of their list. And so I think a lot of our future customers are thinking about how do you use technology specifically to help alleviate these constraints.
What does the FAA say about this? My understanding is that as long as there's someone, a human, steering the airplane, that can be done, right? So not allowed yet to fly fully autonomously with the airplane taking its own decisions with AI or whatever, but you can fly remotely as if it was a drone.
Yeah, we don't like to use the word drone because drone is mostly consumer, and that's a whole separate regulatory base. But what happened is in 2013, here in the United States, the FAA allowed for the first certification basis for remotely piloted aircraft system, or RPAS, which is kind of where Nautilus falls in. And so we've had this regulatory base for about a decade. So there's a number of companies that are pursuing certification under this new rulemaking, which is really exciting for us, cutting edge technology, specifically starting out in general aviation. And so the thinking is right now, the airplane does fly itself. So it makes, I guess, flight decisions, but it's being guided along by a remote operator. And so it's somebody who is also qualified as a pilot of similar experience and rating that navigates the airplane through the national airspace system, talking remotely with air traffic control, and then managing any emergencies.
Mm-hmm.
But because of the latency links between the airplane and satellite communication going down to the remote operator, we don't actually give this remote operator a joystick because can't really fly that airplane with so much latency and help make those really small tweaks, especially on landing. And honestly, airplanes particularly fly themselves today anyway. I mean, the first airplane flight was 1903. First autopilot installed in an airplane was 1913. So we've had this technology for over 110 years, right? So we were just waiting for the need to develop as well as the regulatory environment. And so lack of pilots, as well as the new generation of FAA rulemaking here in the United States kind of opened up the door for this type of solution to airline customers.
Mm-hmm. Yeah, we had here on the podcast Mark Piat of X-Wing
Yeah.
was talking about autonomous flight. Is this a technology you are developing in-house, or you are working with some other technology companies that are working on this type of autonomous flight systems?
I think well, the bulk of the technology is being developed in-house by our team. I think it's easier to do so because you can marry those technologies directly into the bones of the airframe, which is really important for certification. But
Mm-hmm.
at the same time, we do believe that there is certain pieces of technology that we can all work together to help develop. A good example might be the detect and avoid system, which is really key parts of this technology. And so there's not been a lot of very, I would say, certifiable or readily available solutions on the market today. So there's been conversations internally within the ecosystem to help maybe partner up and develop those pieces.
Mm-hmm. I remember you recently released some images of what you call a pod. It's just like a cockpit, but on the ground from where you can control the aircraft.
Yeah, the pod is our first kind of iteration of what a ground control station looks like for
Mm-hmm.
these operators. We're working directly with our future customer, Ameriflight, to help essentially understand exactly what the operational side of the pod should look like, what screens need to be represented with the pilot, well, how much control we give to the remote operator versus how much do we push towards autonomous or automated operations as well. And then even more importantly, how does that all tie into a normal operation for those types of airline customers?
Mm-hmm.
So this was, I would call it a alpha version for us. And there's a lot of still work to do in really maturing that idea, but we're working really closely with our future partners in doing so.
So most of the, let's say, the small things and during the flight are going to be controlled by the autonomously by the system itself, but you're going to have a human on the ground that's going to be monitoring the flight and will be able to step in whenever it's needed to intervene to steer the aircraft or to do something with it. Is that right?
Yeah, I
Maybe
would.
a bit simplistic, but
No. You have it right. So I wouldn't use the word steer, but guide the airplane in case of
okay.
an.
Also in the landings, takeoff, that's going to be a human doing it, or?
Yeah, so takeoff and landing is going to be automated. There's a variety of reasons why. I mean, it's just the latency links alone just don't allow you to do that.
Mm-hmm.
So the airplane can make its own decisions. The technology is there, and so why not push that onto the airplane?
What about the cargo bay? Are there going to be some innovations there in the when it comes to the unloading, loading and unloading of the aircraft, or that's going to be done the traditional way?
So it's something that we've been exploring quite a bit with our future customers. There's interesting technologies available out there. The challenge is that a lot of the operations are done by just they're so I guess I would say rudimentary right now, and they need reliability more than they need more technology within them. So as an example, if let's say you have a what they call power drive unit, which is just the motor on the floor, which helps position the container in the correct location. So we can have those power drive units, PDUs, move automatically the container and lock it into place. But if one of those PDU units gets broken, as an example, the airplane can't dispatch. And so our customers live on reliability. And so there is a kind of a shifting point, whereas there's too much technology, which creates those reliability issues, which prevents the airplane from dispatching, which hinders operation. And so we're starting to understand those types of pain points. Definitely opportunities exist, but the manual labor process of loading and unloading cargo has been so efficient lately that there's very little you can do as far as increasing more efficiency, if that makes sense.
Because how do you load or unload a blended wing body? Is it on the upper part, the lower part of the aircraft, and the side? I'm just trying to figure out what is there like the cargo bay opens up? How?
Yeah. So all of our airplanes have a large side loading door ahead of the wing. And so it's on the triangular side of the facet. So large door comes out. There's usually a loading bridge, which allows for a ball mat to essentially merge with a high loader or a forklift and things like that, where you can slide standard air freight pallets directly into the cargo bay section and latch them up. So it's a
Mhm.
very, I would say, almost industry standard interface, but not for specifically the CONUS size of airplane, which is something new and innovative, which we're bringing to our customers.
What's the feedback you're getting from the industry? How many orders or pre-orders? I don't know if they are still they are already firm orders or just more letters of intent, but how many aircraft have you quote unquote sold until now?
Yeah, so the order book sits at $8.6 billion to date and over 470 plus aircraft across the three platforms. So the value of the order book is more largely tied with the larger platforms, but the number of airplanes more closely with the smaller ones. So the industry has been really looking for something like this for a long time. They've been asking a lot of the traditional OEM players to really think about this, but those folks are so entangled within the passenger sector that $270 billion doesn't seem like a frothy enough market for them to design a separate platform for.
And what about the other way around? Do you see some perspectives for your aircraft to one day become also a passenger carrying aircraft?
I think there's opportunities in the DoD space, the defense markets for it first, and then as one advisor, put it, a good freight aircraft makes for an excellent passenger airplane. So I think there's definitely opportunities for our platform to go in that direction. However, we're largely focused on just getting the solution tuned in for freight today.
I think you mentioned defense. I think there are some renderings out there. I think a refueling concept, air-to-air refueling. I guess cargo as well for the military. That would be another market that you would be in principle looking at.
Yes, that's correct. So the platform makes a lot of or brings a lot of value and meets a lot of requirements on the DoD side for aero refueling tankers. Here in the United States, those tankers are aging out right now, and so there's a large push within the defense budget to start thinking about what does the next generation look like. Completely separate requirements from what currently is going on. So I don't think you can adapt a passenger lookalike airplane for the next generation of aero refueling. And the second piece is strategic airlift. And so all three products seem to make a really good fit for strategic airlift for a variety of reasons. And as well as, within the DoD sector, unmanned technologies have a different place than they do in the FAA. So you can really push the envelope in more of the cutting edge technology spaces. So I think there's a bright future for our products in those sectors for sure.
Does this shape give it some stealth benefits to the aircraft?
It depends.
Okay. What are the next milestones now? Because you basically been racking up orders. Like we had this recent order, I think this same week, just a few days ago, you got an order for a few, how many of the Kona aircraft?
It's 8 airplanes. I think
Air-
the order is about 54, something like that, $1 million in total.
Uh-huh. And you've got already some big operators on board with the concept, yeah? So can you name some of the companies that have ordered the aircraft or express interest in the aircraft?
Yeah, I think we're still trying to keep our customers kind of down low for a variety of reasons as we
Okay.
kind of learn a little bit more about their operations. But some of the biggest ones that have made public is Ameriflight. They operate one of the largest feeder aircraft fleets here in the United States. They see this as enabling technology to allow for more routes and operating or opening up new revenue streams for the business, and helping it grow, which is really important. So they placed an order for over 20 of the Kona regional airplanes. Really excited to work with them and really bringing this new technology into a space that, really needs it right now as well. Then we have some more, I would say, larger operators that have signed up for orders as well that we just haven't been able to announce just yet.
All of them in the US or in other countries as well?
Global level.
Okay. What are the next milestones? What can we expect next?
Yeah, so this is kind of we're entering a phase of the company where it's I would say is exciting on the engineering side, but maybe a little bit more boring on the side marker watching of it. So a lot of the next 24 months is specifically tied to building out the airplane. So purchasing tooling, doing parts manufacturing, turning on suppliers, and kind of getting everything assembled. So it'll get really exciting at marker like 20 months from now, where you start to see what looks like an airplane come together. But over the next year or so, you're just going to see small pieces, scattered around our facility.
Mm-hmm. So you mentioned 2027 for certification. That's the goal. What about entry into service?
So that'll be certification and entry into service is 2027. And then first flight is we're hoping, a little bit over 24 months right now, based on our time schedule.
Okay, very good. Well, wishing you all the best with this very exciting project. Quite a few things here that are very, very interesting on the structure of the aircraft, sustainability, the autonomous flight, also the concept of disrupting this whole segment of the industry that is air cargo. People that wish to learn more, where should they go? What's their website, social media channels that they should check?
Yeah, so www.nautilus.co is our website. It's got links to our social media right now. We have a pretty big presence on LinkedIn. The company's hiring, so if you're a young or experienced engineer that likes to work on cutting edge technology, we'd love to talk to you. And yeah, we'd love to see you apply on our website.
All right, so you heard it here. Apply, go to the website if you're listening this and wish to work in this very exciting project. I forgot to ask one last thing. The name, where did it come from? Because it sounds to me like Jules Verne, sort of. There was this kind of futuristic submarine or something was called Nautilus, I think, with an U. But that's what comes to my mind. But maybe it's a different story.
No, you had it right. So I'm a big Jules Verne fan, and I love 20,000 Leagues Under the Sea. I really liked. There's actually a picture in the original manuscript of the book where it's Captain Nemo in Antarctica, and he punches a flag into the snow, and it's got in Latin, movement within movements is kind of the slogan behind Nautilus. And so I really like that as movement within movements, and I think it kind of fits really well with our products. Unfortunately, I had to take out the U. There was a treadmill company with a similar name, and so for ease of a startup, we decided just to drop it. But the name has been pretty, I think, a good indication of where our mindset is and the future.
Very good. Well, thank you very much for your time today. Wishing you all the best with the project. And yeah, thanks so much.
Thank you, Mikhail. Appreciate it.
If you like this podcast, you can support us by giving it a great rating on Apple, Spotify, or whichever platform you get it from. And remember, you can, of course, subscribe to it. And you can also get regular updates through the Allplane website. That's allplane.tv. We have a newsletter where we cover the aviation industry every week with a special focus on innovation and sustainability. So give it a go. Thank you and goodbye.